Thank you to the organisers for the invitation to speak today. What are the main impacts of climate change? This is the question that CHERISH is trying to address. We are trying to address it by using a range of techniques. We're going to go over some of the technology we're applying. We're also doing it through collaboration, and collaboration is at the heart of the CHERISH project. We're funded by the EU Ireland-Wales programme as part of the European Territorial Cooperation programme, which looks to encourage organisations from EU member states to collaborate on economic, environmental and social issues. And the four partners involved with the CHERISH project: from Wales, there's the Royal Commission on Ancient Historical Monuments, and there is Aberystwyth University, and in Ireland there's the Discovery Programme, and there is the Geological Survey Ireland. And we use the expertise and the experience of the four partner organisations to try and address the issue of the impacts of climate change to sites of cultural heritage. And in terms of what those impacts are, those two images, or those three images on the left, the central one being Hurricane Lorenzo before it made landfall in Ireland as a storm, but at the time was the most easterly and northerly Category 5 hurricane in the Atlantic Ocean. And the IPCC report, the recent IPCC report, suggests that these extreme events are going to become more frequent. And particularly if we look at storms and maybe high magnitude wind and rainfall events superimposed onto rising sea levels, we're going to perhaps look at more coastal flooding occurring, both through storm surge and waves coming from the marine side, and also flooding from the terrestrial side coming down, meeting high waters. And so in the CHERISH project, we're looking at both Welsh and Irish sites. There's about 13 areas in Wales. There's 5 in Ireland, from Dublin, Wexford, Waterford and Kerry, and looking at individual sites of cultural heritage within those areas to try and map, monitor and record change, to provide data for decision makers to best manage these sites going forward in the face of a changing climate. The way that we approach this is to try and take a holistic view of the coastline, to record it using a range of different techniques, building on the expertise of the partner organizations. And I'll focus on some of these, the ones that the Geological Survey has been applying, such as the offshore, the vessels that we've been able to use the resources of the INFOMAR program, vessels like the RV Kieran and the RV Lear, to monitor and record the seabed and wrecks offshore, and to try to tie that on to onshore data, which we've acquired in the intertidal and supertidal area using drones, using LiDAR from airplanes. We've looked at satellite images for regional pictures, and knit that together with terrestrial laser scanning on coastlines. Our partners have then used a lot of the other techniques to look at more of the archaeology and where that sits within the regional picture. And some of the data and some of the scale that we've acquired data over, the images on the left then is satellite data, where we've been able to build on experience within the Geological Survey in other sections of satellite-derived bathymetry to get maybe coarse bathymetric maps of some of our coastal areas. We've then targeted certain areas such as Dublin Bay, and the CHERISH project, in collaboration with other Irish research projects such as Acclimatise and Predict, are then looking to acquire new data from Dublin Bay and hopefully Ireland's Eye to be able to stitch together the terrestrial LiDAR data with the offshore marine data set from the INFOMAR program. We've looked on a kilometre scale. We deployed our UAVs to look at kilometre stretch of coastline. The example here is from Dublin Bay, again trying to stitch the onshore with the offshore, and right down to a metre scale, deployed our scanning total station to look at individual eroding cliff faces, to establish that baseline data from which we can monitor future change. And one of the key elements that the Geological Survey has been focusing on is a generation of elevation models of our coastlines. to then superimpose other data to try and understand what is occurring. And one thing that we've done recently is walkover surveys, rapid coastal assessments in the area of Rush of North Dublin, where with a laptop, where we've been able to geolocate ourselves, sorry, with the tablets, record as we walk along what the erosion is like in that area, and that automatically populates a map which can contain our data, our UAV data from that, to get an information on the ground of what is happening to the sediments on down to a meter scale. We're then able to use other sections within the Geological Survey, specifically the Coastal Vulnerability Index that's being produced and has been produced for the East Coast. A lot of the inputs into that, the wave regime, the tidal regime, can then be used to help inform some of the processes that are occurring, and then some of the impacts that we're then observing on the site. This data then gets married to the archaeology data, and it's being recorded by our colleagues in the Discovery Programme, and along the stretch of coastline that they've recorded new shell middens from potentially about 5,000 years ago, and also I believe it's a Bronze Age burial site that's been newly exposed because of the erosion that's occurring currently along that stretch of coastline. We've also looked at other ways that perhaps we can monitor our coastline, and also as research in the CHERISH project, we're able to get down to sites perhaps once, maybe up to about twice a year, realistically, to record change. But we know that erosion is happening continuously, or that erosion is happening episodically through the year. And so we've gone in collaboration with the Copper Coast Geopark down in County Waterford. Using their volunteers, we have developed an app that they're then able to, as they walk a stretch of coastline, record what they see and changes what they've seen. And so they're able to perhaps record the length of time they've been there previously. Have they identified any change? If they have, what is that change? They're then able to take a photo of it, which is geolocated using their phone, which again automatically populates a map that we're able to see in real time the data come through. And the two images on the left here is some of the data that they have produced. These are rock falls at coastlines, and we're beginning to maybe be able to match what the processes that are occurring with weather events that are there, be it recent rainfall or storm events. And that's what we hope to do, is that over time, we might start to see patterns emerging about when some of these events are occurring, and are they matched to weather events. The image on the right is Clean Coast, on Tashka's Clean Coast, where we've been in collaboration with them in terms of a beach clean and a heritage walk along Bull Island, where we visited some of the CHERISH sites. It's always good to use existing networks of people. The CHERISH project is young. We don't have our own established membership to come to our event, but going in collaboration with other ones helps to ensure a high turnout. And it also leads to future things. So once we've done this event and they heard about the coastal monitoring app, they're interested in trying that with 3 of their groups, and if that's successful, to rolling it out to a wider audience. Looking then at some of the other data that we've collected and the assistance that we've got from INFOMAR, we have access to the inshore survey vessels, 2 weeks in Ireland and 2 weeks over in Wales, and we've been over to Wales 4 times since the start of the project. We've been able to look at offshore sites like islands and reefs to be able to map areas which hadn't been mapped previously, and to survey shipwrecks in higher precision than had been done previously. And over a number of years, we've been able to map almost the entirety of the ridge along Saran Patrick, where there's lots of shipwrecks, and we're able to see what looks like a great big glacial esker sitting along the top of that, which helps to understand the formation of that area, and also helps to give the regional context for the shipwrecks along that site, and then to match up the offshore story with the onshore heritage. The data we collect, we want to integrate so we can use geological maps and quaternary maps to understand what the coastline is composed of, to understand some of the processes. And we're also able to stitch the onshore with the offshore. And the images on the left there of Dalkey Island, we have UAV and LiDAR data that was acquired as part of the CHERISH project. And then the image below it is a seamless coastal terrain model where that has been integrated with the existing INFOMAR data and also new data that was acquired by the RV LUR as part of the CHERISH project, where we've been able to push the vessels up higher to try and match it in with the terrestrial data that we've acquired. The image on the right there is of Puffin Island over in Wales, where we have LiDAR data acquired by our partners, the Royal Commission in Wales, and we've then combined that with bathymetry data acquired by the RV CHERISH as part of the CHERISH project, using the expertise and the technical knowledge of the INFOMAR program in assisting with that. And these then help us to understand the offshore processes, the hydrodynamic processes that are occurring here that could be impacting the onshore cultural heritage. In terms of change, and CHERISH is interested in looking at the change that's occurring at these sites. We can look at the historical sources and the historical maps, and look at maybe the snapshots in time when the maps are produced, to look at the changing coastline. And the image on the left is of Kilmichael Point in County Wexford, and we're able to see an annualized rate of about 2.2 meters per year as that coastline recedes through erosion. And that can be applied in other areas. The other images there is of Portrane in County Dublin, where we have both accretion and erosion near that site. But even over the duration of the project, and in Ireland, the project been running since 2017. It will end in the middle of 2023. So we've been able to survey our sites a number of times. The image on the left there is a DSM of difference of Kilmichael Point in County Wexford and Kilpatrick Beach, where it's been color coded, where blue is land rise, such as deposition, red is land elevation decrease, i.e. erosion. And we are able to see that erosion can be focused in certain areas, particularly along the sand dunes of Kilpatrick Beach, where over the course we have measured between March 2021 and December 2020. We recorded the vegetation line receded by, I think it was over 15 meters, which averages out at about 6 meters per year of vegetation line retreat. We're also able to look at in other areas. The images, the set of images on the right is from Rosslare in County Wexford, where we've done UAV surveys in 2017, 2018, 2019. We've done furthers in 2020 and in 2021. And we're able to look at the difference between those surveys. Again, color coded, so red is erosion, blue is deposition. And that panel D, which is in the center there, is the difference between 2017 and 2018, where there was a little bit of erosion happening. But really, a large part happened between 2018 and 2019. That's the image E there on the right, where we see a large amount of change. And we're beginning to understand the importance of repeat surveys to try and build a picture of what's occurring. And we can do this onshore. We can also do it offshore. So again, using the collaboration with INFOMAR, the data from INFOMAR, they surveyed the City of London wreck in 2015 off the coast of Wexford, and then CHERISH has returned with the RV CHERISH in 2018 and 2020. We've also gone back in 2021 to resurvey it. And we're able to build up a complex story of change occurring in this area. These are the central images, where blue is deposition, red is erosion. And starting at the top there, between 2015 and 2018, we see deposition in the area, followed by beneath that erosion, where there's a lot of red between 2018 and 2020, such that the medium term change, the one at the very bottom, is one of erosion occurring at this site. And again, is the repeat surveys which allows to build up this picture of what's happening. We also have collaborated with the University of Limerick, and they put their ROV on board the RV CHERISH, and we've been able to survey the La Surveillance in Bantry Bay and Manchester Merchant in Dingle, take video and images to produce photogrammetry of these wrecks, which will then be able to stitch with the bathymetry that was acquired by the CHERISH at those sites. And we're looking forward to seeing the data coming from that in the next few months. So just to finish up, all the data that the CHERISH project produces is freely accessible. We'll be releasing it through portals of each of the different project partners. There's already UAV data up on the GSI's Open Topographic Viewer. This data then acts as a baseline from which the CHERISH project itself can monitor change, but in the future, other organizations can also measure change to try and understand the processes that are occurring. And we're looking at them producing detailed management plans for our key sites so that they can be best managed going into the future in the face of a changing climate. And we are looking at really getting this data and information into the hands of local communities so that they're able to use it, that it can benefit their areas and benefit the blue economy. And on that, I'd like to say thank you very much to you all for listening. So thank you.